Boeing just transformed a 50-year-old fighter into the most lethal air dominance machine on the planet. The F-15EX isn't your grandfather's Eagle. It's a technological monster that makes billion-dollar stealth fighters look outdated. The F-15 Eagle first flew in 1972. That's over 50 years ago. Most people assume that anything that old must be obsolete by now. Military analysts predicted the Eagle would be retired years ago, replaced by newer designs with better capabilities. They were completely wrong. The F-15EX represents something unprecedented in military aviation history. Engineers took an airframe design from the 1970s and packed it with technology that won't exist in most fighters until the 2030s. We're talking about capabilities so advanced that even America's newest stealth fighters can't match them. Here's what makes this absolutely incredible. The original F-15A could carry 8 air-to-air missiles and had analog instruments in the cockpit. The F-15EX can carry 22 missiles and features displays that look like they came from a science fiction movie. Radar in the F-15EX is more powerful than the radar systems on many naval destroyers. The electronic warfare suite can jam enemy communications across an entire battlefield. The weapon systems can engage targets that pilots can't even see with their own eyes. But the most shocking part isn't what the F-15EX can do. It's how much better it performs than aircraft that cost twice as much and took decades longer to develop. The Air Force tested the F-15EX against simulated enemies using the latest Russian and Chinese fighter tactics. The Eagle didn't just win these engagements, it dominated so completely that test evaluators had to make the scenarios harder just to create a fair fight. Think about what this means. A design from 1972 equipped with modern technology outperforms aircraft designed specifically to counter it. Step inside an F-15EX cockpit and you'll immediately understand why this aircraft represents a complete paradigm shift. 2 massive touchscreen displays dominate the forward panel. These aren't like the screens in your car or phone. These are ruggedized military displays that remain perfectly readable in direct sunlight, at night, or while pulling 9G turns. The displays show everything simultaneously: tactical situation, weapon status, aircraft systems, electronic warfare picture, data link information from other aircraft and satellites. Pilots can customize the layout to match their preferences or mission requirements. Compare this to older F-15 variants with dozens of individual gauges, switches, and indicators. Pilots spent years learning where everything was located and how to read it all quickly during combat. The cognitive workload was immense. The F-15EX reduces that workload dramatically. Information appears exactly where pilots need it, formatted in ways that make sense, instantly. Threat warnings highlight automatically. Weapon solutions appear as soon as they're available. System malfunctions identify themselves clearly. This might sound like a minor improvement. It's actually transformational. Fighter combat happens at incredible speeds. Decisions must be made in seconds or less. Anything that reduces the time between recognizing a situation and acting on it provides an enormous advantage. The F-15EX cockpit gives pilots that advantage. They process information faster, make decisions quicker, and act more precisely than opponents flying older aircraft. But the cockpit represents just the visible part of the technological transformation. The real magic happens in systems that pilots never see directly. If you think American engineering excellence is something worth celebrating, type excellence in the comments below. The AN/APG-82 AESA radar in the F-15EX represents one of the most capable air-to-air radar systems ever installed in a fighter aircraft. AESA stands for Active Electronically Scanned Array. Instead of a single large antenna that physically rotates, AESA radars use thousands of tiny transmitter-receiver modules arranged in a flat panel. Each module operates independently under computer control. This architecture provides capabilities that traditional radars simply cannot match. The APG-82 can track multiple targets simultaneously while scanning for new threats and jamming enemy radar systems, all at the same time. A traditional radar must choose between these functions, switching rapidly between modes. The range exceeds anything publicly acknowledged. Military sources hint that the APG-82 can detect fighter-sized targets at distances exceeding 150 miles. That's further than most air-to-air missiles can shoot. But detection range tells only part of the story. The APG-82 can identify aircraft types, track their movements, predict their intentions, and even detect when enemy pilots turn on their own radar systems. This creates a tactical situation where F-15EX pilots see enemy aircraft long before those enemies know the Eagle is nearby. In air combat, seeing first usually means shooting first. Shooting first usually means winning. The radar also functions as an electronic warfare tool. It can focus intense energy on enemy radar systems, temporarily blinding them or even causing permanent damage. Imagine firing your radar like a weapon, frying enemy sensors from dozens of miles away. The APG-82 does this while simultaneously tracking friendly aircraft, coordinating with other sensors, and maintaining complete situational awareness. The computer processing power required for these functions exceeds what entire military installations had available just 20 years ago. The F-15EX can carry more weapons than any other American fighter in service. Period. We're talking about payload capacity that exceeds some bomber aircraft. The maximum weapons load reaches 29,500 pounds. To put that in perspective, that's heavier than 6 Honda Civics. All of that weight can be munitions specifically chosen for whatever mission the aircraft flies. But raw capacity means nothing without sophisticated integration. The F-15EX weapon systems represent a masterpiece of modern engineering. The aircraft can employ every weapon in the American arsenal. AIM-120 AMRAAM missiles for long-range air-to-air combat, AIM-9X sidewinders for close-range dogfighting, Joint Direct Attack munitions for precision strikes against ground targets, cruise missiles for standoff attacks, even hypersonic weapons too large for any other fighter. The fire control computer manages all of these options automatically. Pilots select targets, and the computer determines the optimal weapon for engagement, distance, target type, atmospheric conditions, aircraft speed, and altitude all factor into the decision instantly. Multiple weapons can be programmed to attack the same target from different angles simultaneously. This overwhelms even the most sophisticated air defense systems because they can't engage threats coming from multiple directions at once. The computer also manages weapon separation to prevent mid-air collisions between munitions. When you're launching 12 missiles in rapid succession, ensuring they don't interfere with each other requires precise calculations happening faster than human reflexes allow. Wait until you hear about the electronic warfare capabilities. This is where things get really interesting. Modern air combat isn't just about missiles and maneuvers, it's about controlling the electromagnetic spectrum. The side that dominates electronic warfare usually wins the battle regardless of other factors. The F-15EX Eagle passive active warning survivability system makes this aircraft an electronic warfare powerhouse. The system detects modern air combat isn't just about missiles and maneuvers, it's about controlling the electromagnetic spectrum. The side that dominates electronic warfare usually wins the battle regardless of other factors. The F-15EX Eagle passive active warning survivability system makes this aircraft an electronic warfare powerhouse. The system detects enemy radar emissions automatically. When a threat radar illuminates the F-15EX, the system identifies what type of radar it is, where it's located, and what weapons might be associated with it. This happens in milliseconds without pilot input. The system then recommends countermeasures. Should the pilot turn to minimize radar cross-section? Should the aircraft jam the enemy radar? Should chaff or flares be deployed? The computer provides the answer instantly based on threat type and tactical situation. But defensive capabilities represent only half of the electronic warfare equation. The F-15EX can go on the offensive. The aircraft can jam enemy radar systems, making it impossible for them to track targets accurately. It can spoof enemy missiles, making them think the aircraft is somewhere it isn't. It can even insert false targets into enemy radar displays, creating ghost aircraft that don't exist. These electronic attacks can be precisely targeted. The F-15EX can jam specific enemy units while leaving friendly sensors completely unaffected. This precision prevents the electronic fratricide that plagued older systems. The electronic warfare suite also provides intelligence gathering capabilities. Every enemy radar emission gets recorded and analyzed. This information helps military planners understand enemy capabilities and develop better tactics for future engagements. Think of the F-15EX as a flying intelligence platform that also happens to carry enough missiles to destroy an entire enemy squadron. The F-15EX uses two General Electric F-110GE-129 engines. Each engine produces 29,000 pounds of thrust with afterburner. Combined, that's 58,000 pounds of raw power pushing the aircraft through the sky. These aren't just powerful engines, they're smart engines with digital controls that optimize performance continuously. The full authority. Digital engine control systems monitor hundreds of parameters every second. Temperature, pressure, fuel flow, vibration, and dozens of other factors all feed into computers that adjust engine operation in real time. This constant optimization provides benefits across multiple areas. Fuel efficiency improves because engines run at ideal settings for current conditions. Reliability increases because the system detects potential problems before they cause failures. Performance maximizes because engines always deliver precisely the thrust needed. The engines push the F-15EX to speeds exceeding Mach 2.5. That's over 900 miles per hour. At that speed, the aircraft can cross the entire state of Texas in less than 30 minutes. But top speed matters less than sustainable speed. The F-15EX can supercruise, meaning it can maintain supersonic speeds without using afterburners. This dramatically extends range because afterburners consume fuel at enormous rates. Supercruise also provides tactical advantages. The aircraft can dash to intercept points at supersonic speed, engage targets, and return to base without the fuel penalties that afterburners create. The engine power also generates massive amounts of electrical power for aircraft systems. The radar, electronic warfare equipment, cockpit displays, and computers all require electricity. The F-15EX generates more electrical power than most houses use. This electrical generation capability positions the aircraft perfectly for future weapon systems. Directed energy weapons like lasers require enormous electrical power. The F-15EX could potentially mount such weapons as they become operationally viable. Before we go further into this incredible story, please hit that subscribe button if you haven't already. We bring you military aviation content that you won't find anywhere else, and subscribing helps us continue creating videos like this. Did you subscribe? Excellent. Let's continue. The F-15EX looks similar to older Eagle variants from the outside, but the structural improvements represent some of the most significant changes in the entire aircraft. Engineers completely redesigned the airframe using modern materials and manufacturing techniques. High-strength aluminum alloys reduce weight while increasing durability. Advanced composites in key areas provide strength without adding mass. The wing structure received particular attention. New spars and ribs handle the stress from carrying maximum weapons loads while maintaining structural integrity through aggressive maneuvers. These improvements extend the aircraft's service life dramatically. The original F-15A was designed for 8,000 flight hours. The F-15EX is rated for 20,000 flight hours. That's 2.5 times longer than the original design. 20,000 flight hours translates to decades of operational service. An F-15EX entering service today could still be flying combat missions in the 2060s. Your grandchildren might serve on aircraft that entered the fleet before they were born. The structural strength also enables higher G-loading. Fighter maneuvers subject aircraft to extreme forces measured in Gs, or multiples of gravitational acceleration. The F-15EX can sustain 9 G turns repeatedly without structural damage. 9 Gs means the aircraft and pilot experience 9 times their normal weight. A 200-pound pilot weighs 1 or 800 pounds during a 9 G turn. The aircraft must handle these forces across its entire structure simultaneously. The ability to pull hard maneuvers repeatedly gives the F-15EX a significant advantage in close-range combat. Pilots can push the aircraft to its limits, knowing the structure will handle the stress. This section might sound technical, but it represents one of the most important features of the F-15EX. Open Mission Systems architecture means the aircraft uses standardized interfaces and protocols for all its major systems. Instead of proprietary connections that only work with specific equipment, the F-15EX uses industry standards that allow plug-and-play upgrades. Think of it like USB ports on your computer. You can plug in different devices without worrying about compatibility because everything uses the same standard. The F-15EX applies this concept to military avionics. New sensors, weapons, displays, or computers can be integrated relatively quickly because they don't require custom interfaces. This architecture provides enormous benefits over the aircraft's service life. As new technologies become available, they can be installed on the F-15EX without major modifications. Software updates can add capabilities that didn't exist when the aircraft was built. Compare this to older aircraft with custom interfaces for every system. Upgrading those aircraft requires extensive engineering work to create new interfaces. The cost and time required often makes upgrades impractical. The F-35 suffers from exactly this problem. Its highly integrated systems provide capability but prevent easy upgrades. Changing one system often requires modifications to multiple other systems because everything interconnects in complex ways. The F-15EX sidesteps this issue entirely. Systems operate independently using standard interfaces. Upgrading the radar doesn't require modifying the electronic warfare suite. Installing new weapons doesn't affect the flight controls. This flexibility ensures the F-15EX remains relevant for decades. Technologies that don't exist yet can be integrated as they become operational. The aircraft you see today represents just the baseline capability. Here's something that will completely change how you think about fighter aircraft design. The F-15EX operates as part of a network rather than as an independent platform. This networking capability multiplies its effectiveness exponentially. Link 16 data link connects the aircraft to other fighters, bombers, tankers, surveillance aircraft, and ground stations. Information flows continuously in all directions, creating a complete picture of the battle space. When an F-15EX radar detects a target, that information transmits automatically to other aircraft in the network. Multiple fighters can track the same target using different sensors from different angles. This network tracking provides far more accurate information than any single aircraft could gather alone. The network also enables distributed combat tactics. F-15EX aircraft can coordinate attacks without radio communication that enemies might intercept. Complex tactical maneuvers execute automatically with computer precision. Imagine 4 F-15EX fighters approaching enemy territory. Their radars operate in coordinated mode, each covering a different section of airspace. When they detect enemy aircraft, the computers calculate optimal engagement geometry and weapon assignments automatically. The pilots approve the plan, and the attack executes simultaneously. 4 Eagles launch missiles at the same instant from different directions. The enemy doesn't face one threat, they face a coordinated assault designed by computers that can process tactical options faster than human minds. This networked approach transforms individual aircraft into components of a larger weapon system. The total capability exceeds the sum of individual parts. The data link also connects to space-based sensors, ground-based radar systems, and intelligence platforms. An F-15EX pilot sees not just what their own sensors detect, but what every sensor in the theater detects. This information advantage cannot be overstated. Knowing where every enemy aircraft is located before they know you're there determines the outcome before the first missile launches. Military aircraft must be maintained regularly to remain airworthy. The complexity and frequency of maintenance directly impacts operational capability. The F-15EX was designed specifically for easy maintenance. Components that require frequent service are easily accessible. Diagnostic systems identify problems precisely, eliminating hours of troubleshooting. The aircraft achieves an 83% mission-capable rate. That means 83% of F-15EX aircraft are ready to fly combat missions at any given time. Only 17% are down for maintenance or repairs. Compare this to the F-35 with mission-capable rates hovering around 50%. Half the fleet sits on the ground waiting for parts or repairs. This difference becomes exponentially important during sustained operations. If you have 100 F-15EX aircraft, you can count on 83 being available for missions. If you have 100 F-35s, only 50 are typically available. The F-15EX also requires fewer maintenance hours per flight hour. For every hour the aircraft flies, maintainers spend about 6 hours performing inspections and service. Modern fighters often require 20 or more maintenance hours per flight hour. This reduced maintenance burden means smaller ground crews can support larger numbers of aircraft. Logistics requirements decrease dramatically. Forward operating locations don't need massive maintenance facilities. The simplicity extends to the supply chain. Many F-15EX components use standardized parts available from multiple suppliers. This prevents single points of failure where one manufacturer's problems ground the entire fleet. Contrast this with proprietary systems where parts come from single sources. If that supplier has problems, the entire fleet. The Air Force is developing unmanned combat aircraft that fly alongside manned fighters. These collaborative combat aircraft will extend the reach and capability of traditional fighters exponentially. The F-15EX was designed from the beginning to control these unmanned wingmen. The cockpit displays include interfaces for commanding multiple drones simultaneously. The data link systems can maintain connections with several unmanned aircraft at once. Imagine an F-15EX approaching enemy territory with 4 unmanned wingmen. 2 drones carry additional air-to-air missiles, extending the Eagle's effective weapons load. 1 drone specializes in electronic warfare and jamming. The 4th carries sensors that expand the formation's detection range. The F-15EX pilot commands this entire package from their cockpit. The manned fighter remains safely outside the most dangerous areas, while the unmanned aircraft push forward into high-threat zones. If enemies destroy a drone, no American pilot dies. The drones cost a fraction of what manned fighters cost, making them acceptable losses in situations where risking pilots would be unacceptable. This concept multiplies F-15EX effectiveness without requiring more pilots or more expensive aircraft. The Eagle becomes the quarterback of an aerial team rather than operating alone. The open architecture allows integration with multiple unmanned aircraft types as they become available. The F-15EX isn't locked into one specific drone design. It can work with whatever unmanned systems prove most effective. This flexibility positions the Eagle perfectly for the next 30 years of aerial warfare. As technology evolves and new unmanned platforms enter service, the F-15EX adapts to incorporate them.